Okay, this is the class for the second lesson in chapter 6. It relates to hypothesis testing. So we're doing 6.5 is the content area in the chapter if you're looking for the reading related to hypothesis testing. This week you have an Excel assignment as usual. That's due Thursday night, midnight. And there's also the quiz because this is the last week for chapter 6. And team 3 is going to wrap things up by doing the case for chapter 6. And the Excel file, the last due date on that is Friday midnight. And then I'd like you to get the Zoom presentation uploaded by then too, if possible. So team 3, if you need extra help, be sure to reach out. Okay. So I'm going to go through some of the content here inside the chapter and then show you some examples of how to actually run the statistical test so you can make decisions about these various hypotheses that you're going to make about data sets. So let's first talk about, I'm going to open this up, there we go, the difference between a null hypothesis and an alternative hypothesis. So we say the tentative conjecture, what that really means is the core assumption, right? The core assumption is called the null hypothesis. And the opposite of that is called the alternative hypothesis. And hypothesis testing uses data from a sample to test the validity of these two competing statements. That's the purpose of this. Okay, so this is, depending upon your situation, the hypothesis can take on 3 different forms. So I like to tell students that this alternative hypothesis is really what you want to look at when you're trying to figure out if it's a one-tailed test, two-tailed test, if it's in the lower tail or the upper tail. So here's how you sort it out. The one-tailed tests are going to be these inequalities. So these first 2 are one-tailed tests. And this first one here would be the lower tail because the sample mean, that's what this stands for here, is less than or outside, beyond, right? Lower than, lower tail. Lower than the hypothesis mean that you're trying to test. So it's beyond that, outside of it. In the lower tail, less than the hypothesis mean. So think of the hypothesis mean as the middle of a normal distribution. The sample mean is to the left of that, lower than, when you're looking at the graph. And then this one's the other tail, so the upper tail. The sample mean is greater than, so it's on the other side, on the right. If you're looking at the graph, you got the null hypothesis is in the middle, the normal distribution, that's the mean. You're testing the sample to see where it is relative to this mean, and it's greater than, so it's to the right of the mean on the graph, and it's in the upper tail. So use the alternative hypothesis to help you figure out what tail it's in. And then this here is your two-tailed hypothesis, so meaning that it's not equal to this. It could be greater than or it could be less than. So you're not establishing what side it's on, right? Whether it's greater than or less than, you're just saying it's not equal to. So it could be either greater than or less than. So that's why you're picking up both tails of the distribution. Okay, so that's really important. And then this is really important too, this type 1 and type 2 error. So if you look at this matrix, you got the null hypothesis here. So your assumption is that it's true, right? And then this is the alternative hypothesis is true. Okay, so this is the condition. This over here is conclusion. So if you say, I'm not going to reject that this is true, you'd be making the correct conclusion, right? And then over here, if you're not going to reject, but this is true, this condition is true, then you'd have what we call a type 2 error, meaning that you didn't reject the null hypothesis when you should have, okay? So you assumed that it was true, and in fact, it wasn't true, okay? And then this other conclusion here is where you would reject the null hypothesis. So if you did do that, you rejected the null hypothesis and it was true, then you'd have what we call a type 1 error. If you reject the null hypothesis and HA is true, then you made the right decision, right? So that's going to work out when you make that decision. So what we say in hypothesis testing is that we can control for the type 1 error by using a level of significance. So we can say that I'm willing to tolerate to a certain degree that there is a type 1 error, and we call that a significance test. And we do that by establishing, so we as a researcher have to establish what % we're willing to tolerate. And usually it's 1% or 5% that we're willing to tolerate. Okay, so a 99% confidence interval or a 95% confidence interval is generally what we test, because they line up really well with 1 standard deviation away from the mean and 2 standard deviation away from the mean and 3 standard deviation away from the mean, which is what we generally work with when we have a normal distribution. All right, so this other type of error, however, we're not going to control for in this lesson. So it's not that it's not possible to control for it, it's just we're not going to cover that process in this lesson. So because of that, we can't say here except, right? We can't, if you look at your conclusion possibilities, we don't say accept or reject. We say do not reject or reject. And I know it's a little bit of negative thinking here, but essentially what we're saying there is there's not enough evidence to convince me that I should throw out the null hypothesis. So we don't go so far as to say that I accept the null hypothesis. We just say there's not enough evidence to convince me to throw it out, right, to go with the alternative. And so in that case, you're not making a type 2 error. You're not saying accept the null when the alternative is true. Okay, so you're not going that far out. Now, it is possible to test for a type 2 error, but we're not going to do that in this class. All right, so we're only going to control for type 1 errors. All right, so like I said, the researcher is the one who sets up the percentage that they wish to test at. And so again, we're saying what % probability do I want to take that I might make a type 1 error. So like I said, we usually use 1% if we want a 99% confidence interval, but 99% of the data points would show up within that range, or 95% or 5% level of significance. I'll give you examples of both. All right, so to do this, we calculate this t-test statistic. And what this tells us is the number of standard deviations away from the mean that we are with respect to the sample that we're studying. So I'll show you how that works in an example. And then we also calculate something called the p-value. And the p-value is the probability that provides a measure of evidence against the null hypothesis provided by the sample. So smaller p-values indicate more evidence against HO. So here's the way we use it. We would say that if the p-value is less than the level of significance, which like I said is either 1% or 5%, we would reject the null hypothesis. And if this doesn't hold true, then we don't have enough evidence to reject. All right, let's look at Hilltop Coffee and how they employs. One is a one-tailed and a lower-tailed test, and the other one is a two-tailed test. Okay, so here's the Hilltop Coffee. What we have here is 36 cans of coffee, and we've weighed each can. So each can says that there's 3 pounds of coffee in it. So our null hypothesis is that each can is going to have an average weight of at least greater than or equal to 3. All right, and then we would reject this hypothesis if we found enough evidence to prove that the average weight of a can is less than 3 pounds. So because there's 36 cans, the degrees of freedom are 35. We're going to need that for our t-test. And then this is the hypothesized value that the can says there should be 3 pounds of coffee in there. And we're going to try to prove if this assumption is correct. And so that's why the null hypothesis is set up this way. Now you could set this up to say, let's say the mean is equal to 3, but you wouldn't expect the company to overfill the cans. In fact, you're not concerned about that. if they've advertised there's 3 pounds in there and they give you 3.05 pounds, well, then you got a deal, right? Because it's priced per pound. They're only concerned if the company is underfilling their cans, right? You're only concerned if they're trying to deceive the public. That's the general idea here. All right, so I did the descriptive stats on these 36 cans, and it turns out that the mean weight in each can is less than 3. So what we want to know is this statistically significant in terms of the difference? It is below 3. Right? So is that meaningful, in other words? Can I use that as an estimate to say, yeah, all these samples are going to be generate a mean less than 3, and then take the company to task on whether they're underfilling their cans or not, using this as evidence to support the fact that we believe that they are underfilling the cans. All right, so to run the test to see if this holds up, if there's significance here, we do a t-test, test statistic. And that is the mean of the sample minus the hypothesized mean. So 2.92 minus 3 divided by the standard error. So that is 2.824, which, if you remember the z-score for a 1%, we're going to do a 1% level of significance. The z-score for that is 2.58. And this is outside of that. So if you remember what that means is that the value to meet our criteria for a 1% level of significance, the value can be from 0 to 2.58 on either side. So 0 to 2.58 or 0 to negative 2.58. If it's in that range, then we would not have enough evidence to reject the null hypothesis. If it's outside of that, bigger than, right, on a positive side or on the negative side, then we would say there is some evidence that we would reject. Okay, so this one is bigger than that. So this is providing some evidence. And this here, the p-value, is another way of getting the same evidence. Remember, this is a lower tail test. How do you know that? Because it's less than the mean, right? We're trying to see, is the sample less than the mean? And is that difference significant? So it's a lower tail test. So to run that out, you use t.dist. You put in the t-stat, the degrees of freedom, which remember is 1 minus n, or n minus 1. True, right, because it's cumulative. Okay, so that is your p-value. And the rule is if the p-value is less than the level of significance, 1%, then we would reject the null hypothesis. You can also do a confidence interval on that. So look, this is what you use. Remember, we did this last week. So take the mean and you subtract this, and you take the mean and you add it. And so if 3 is not in that range, you would reject, right? Reject the null hypothesis. Not in here. It's outside. It's in the tails. Okay? So 3 is not in that range. This is below, so it's a lower tail test, right? Makes sense. Okay, and let's look at this one, the mean holiday toys. Same idea. Except this one, we're testing whether or not we expect these retailers. So here's the data. We got 25 samples. They were surveys. And we asked our customers how many units they would order of this new toy we are building for the holiday season. And so this is what they told us, these many toys. The average of that was 37.4. What we're testing is the average of 40. So we're trying to determine if the customers will order on average 40 units of a new toy that they've developed. And we don't care if it's more or less, so that's why this is a two-tailed test, right? So hypothesis is equal, the mean is equal to 40. The alternative hypothesis is not equal to 40. You know, it'd be bigger and it might be less. And we're going to use a 5% level of significance in testing the hypothesis. All right, so when we do the t-stat, same way we did it before, take the sample mean minus the hypothesis mean, divide by the standard error. Notice that it is within the range of a 95% confidence interval, which is 1.96. It's within that range. So this is not giving you enough evidence to reject that the mean is 40. You do the p-values too. Remember, we're doing a two-tailed test because it's in equals. Right? We don't care if it's greater or less. We just want to know if it's different. So it's a two-tailed test. So I set it up. So here I'm doing t-dist, t-stat, the degrees of freedom, true. And then this is 1 minus that to get the upper tail. And then you take 2 times the min of these two to get the tails. All right, notice that's greater than 5. So we don't have enough evidence here to reject. And if you want to do the same thing with confidence interval, I did it 2 ways. You can do it just by using this, that's perfect. Or you can use this function, right, to get the t value to then get the confidence interval. So that's how that's derived. Notice that this includes the 40, right? So the distribution, the confidence interval here is wide enough to pick up that 40. So you can't reject the idea that the average quantity is going to be 40. All right, let's go back. Here we go. All right, so these are the steps that you would use. These are the steps that you would use for hypothesis testing. Step 1, develop the null and alternative hypothesis. Then specify your level of significance. Remember, that's either 1 or 5%. Collect your sample and get the value of your test statistic. Calculate the p-values. Then reject the null hypothesis if the p-value is less than or equal to alpha, which is the level of significance. That's what this is. Interpret the statistical conclusion in the context of the application. So those are the steps that we just took. Okay, now we also test the hypothesis of a population proportion, and that's for categorical data, right? So what percent are females? What percent said yes? Something of that nature. And it's set up the exact same way. So this is a lower tail test, this is a higher upper tail test, and this is 2-tailed test. Same idea. This is your z-score. Instead of a t-stat, we call it a z-score, z-stat. Okay, so that's what you're going to do there. And then let's look at an example. I'm pretty much done. Okay. So this is a golf club, and they're trying to test whether or not the female members that they have are at least 20% of their membership. So the null hypothesis is that the proportion of females is less than or equal to 20%. And we'll reject that if we have enough evidence to indicate that it's actually greater than that. Okay, so this is going to be an upper tail test because the alternative, notice, is P would be outside of that on the right-hand side, greater than, if you're looking at a graph of it. We're going to use a level of significance of 5%. So when I did a count of this, you use count A because it's a categorical data and you need to do it. Count A will only work for categorical data. And then I counted the number of yeses, in other words, females. So I highlighted count if that range has female in it. There were 100 of them. That's 25%. Okay, and we're testing to see if the entire population has 20% or less, right? So the null hypothesis is the portion is less than or equal to 20%. And our sample come out at 25. So now we got to test to see if this is significantly different. So you got to do that standard error, which is the square root of the proportion times 1 minus the proportion over the sample size, which is 400. And you got to do the z, which notice looks really similar to the t. So it's the proportion you calculated minus your hypothesized proportion divided by this standard error. And notice that is well beyond the 1.96 for a 5% confidence interval. So we're probably going to reject this, right? And you got to do the upper tail, right? Because your alternative hypothesis is the proportion is greater than that on the outside, on the right side, upper tail. So first, let's do, notice the function I'm using here. It's different. Norm.s.dst, which is the same process. You put in the z-score and you say true. That's the lower tail. Then you do 1 minus that to get the upper tail, and you do 2 times the min of those two to get the 2-tailed. We're doing an upper tail, so we want to test that. It is in fact lower, so we would reject the hypothesis, null hypothesis. You can also do confidence interval. So we take 1.96 times the standard error, and then we subtract that from the proportion, and we add that to the proportion, and you'll notice that that range is higher. So the actual 0.2 is less than that, right? So it's not in this range, we would reject the null hypothesis. Okay. Okay. So the last part of this class related to big data, and I just wanted to throw this in here. If you think about it, most of the data that companies have now is big data, and hypothesis testing is going to be very important for companies because we can't necessarily work with these gigantic data sets all the time. We're going to have to pull samples from them and test those samples to see if we feel like the results we got from that sample are statistically significant, meaningful, right? Meaningful is what that means. All right, so there is a YouTube video, an extra one if you want to watch it. It's a different person than me explaining how this all works. That might be helpful. And then there's the homework assignments. I gave you the videos for those, so make sure you check them out. And then one more time, here's your due dates. So homework on Thursday night, quiz on Friday night, that's everybody. And then team 3, you got a case to get done. So reach out to me if you need help.